What's up, guys? Preparing a video for you on our review for our Calc 2 final. This is for part 15 from the notes. The question I'm giving to you, see on the bottom there, is find the integral of 3x squared times cosine of 2x dx using integration by parts. I think about some other videos you can watch. Remember some notes that we talked about in order to do this. Reminding you of the acronym LIPIT, which reminds us that we choose the U from not logarithms or inverse trig, but from polynomials ahead of actual trig, the t at the end. Again, it's exponentials and trig. So setting up my u column, or my du column, really, it's 3x squared, then 6x, then 6. And a little reminder, the integral of cosine of 2x is 1/2 of sine 2x. You got to check it, so actually do the derivative. See if it takes you back to like the row up above it. It does work, so we continue to use that structure all the way down. The antiderivative of 1/2 sine of 2x, there it is. And the antiderivative of negative 1/4 cosine of 2x, there it is. And then we just keep, change, or no, keep, change, keep, plus, minus. You know what? You do it. You finish this one. All right, let's go to the next question. Another one. In this question, this is question 9 off of that same page. Remember, it's the whole page that's there. Now I want to do the one on partial fractions. If I could embed videos, I would. And I'd say, go watch this video to see how to do partial fractions. And guess what? It's a whole thing. There are several videos that I've posted that you could get a chance to do here. So if at any point you're like, what is he doing with partial fractions? There's lots of resources out there and watch. The key thing is you look for factors of the denominator. So you got to factor that quadratic, x minus 4 times x plus 2. And when you do that, you then split or separate those denominator factors into their own like fractions. This is multi-days of trying to get this question finished, so it's recorded, and I want to make sure you knew that I did try to capture it, but I'll go back and do the next part. So just stay tuned, keep watching. Here it is. First fraction, a over x minus 4 and b over x plus 2 is equal to the original, integrand. We want to get a common denominator. That's part of the whole break it apart to then recombine it. So in order to get a common denominator, a is missing the factor of x plus 2 top and bottom of its fraction. Same thing, b is missing x minus 4 top and bottom. Now we don't have to really pay attention to the denominators because they're the same on both sides of the equation. So long as x doesn't equal 4 or negative 2, we're good. But the numerators must be equal because they're equal fractions. So distributing out a and b, we get an expression that equals 5x minus 11. And we're going to specifically pay attention to the 5 and the negative 11. The things that are multiplying x, a plus b, equal 5. Because on the other side of the equation, it's 5x. The things that don't have an x next to them, the 2a minus 4b, those equal negative 11 because they're just constants. They don't have an x like factor. So they equal the coefficient, the constant term on the other side of the equation. We're going to write a systems of equations then. A plus b equals 5, and 2a minus 4b equals negative 11. Now, those are the coefficients that we're focused on. So keeping that in mind, here's how we keep using this one. There's several methods. Again, the other videos that I talk about allude to those methods, and go back to Algebra 2 or Algebra 1, or even 8th grade. 8th grade, you started to do systems of equations. But anyway, the point is there are methods that you need to know about in order to solve them. I'm using the method of elimination. I'm multiplying the top fraction by negative 2, and then I'm adding it to the bottom fraction. And by doing that, I'm getting rid of a. One equation, one variable, one unknown. Solve for it. Since I know that b is 7 over 2, I can go back to either equation, but the smart choice is the top one, and replace b with what I now found it to be, 7 over 2. And get a equals 3/2. So my integral with 5x minus 11 over x squared minus 2x minus 8, don't forget there's a dx at the end of both of those, we can rewrite as the integral of, 3 over 2 times, or on the denominator, x minus 4, plus 7 over 2, in the denominator is also x plus 2. Since the 7 and the 2 and the 3 and the 2, those are coefficients, constant terms, they're going to get pulled out of the integral. And we're just looking then only at 1 over x minus 4, or the integral of 1 over x plus 2. Reminder, that looks like something that we've seen a lot. A little go back rule time is that the integral of 1 over x plus a number use a u substitution and a du substitution, and we wind up with, oh, it's the natural log of the absolute value of u. Or if we put what u was substituting back in, the natural log of x plus a, its absolute values, plus c. So just apply that right here. And you know what? Come to think of it, your turn. You do this one. Thanks for watching this video. Thanks for commenting, liking, and subscribing. I want to leave you with the meme of the day since we talked about systems of equations. Don't forget your negative signs. Thanks for watching. Thanks for doing some math with me. See you in the next video.